This is a problem that kind of tests our understanding of what exactly is a trigonometric function, and then specifically, what are a couple of values of trigonometric functions. One of the first things to remember here is that this and this, these are the arguments of the trig functions. It's like if I had f of x plus f of y, well, let's not put a y here because that gets confusing. Let's put f of p. In this function here, the x is my input, and in the same function, my p is the input. So the x and the p are my input values. If I was adding them together, I would not be looking for f of x plus p. That doesn't make any sense. I want to find out what is the value of f of x, and then what is the value of f of p. So that we'll call this value a, and we'll call this value b, and then I would just add a plus b. So the trigonometric functions, cosecant, secant, sine, they're just functions, and these are the arguments of the function. These are the input values of the function. So I definitely do not want to add negative 4 pi over 3 plus 11 pi over 6. That is not what we're doing. That would be adding the arguments. And really what I want to do is I want to get a value for that and a value for that, and then I want to enter it. Because all the trigonometric functions, so let's take sine as an example, then I have an argument which is theta, and that produces some kind of a number. That's what we're looking for. We want to add those numbers up. So let's start with cosecant negative 4 pi over 3. Well, I know if I have my 6-pack, that cosecant is the reciprocal of sine. So if I can find sine of negative 4 pi over 3, then I can easily find cosecant of negative 4 pi over 3. So let's go take a look at our unit circle. Figure out where is negative 4 pi over 3. Well, I can look at my pi over 3 angles. So my pi over 3 angles, here's 1 pi over 3, here's 2 pi over 3, this is 3 pi over 3, which is pi. Here's 4 pi over 3, here's 5 pi over 3, and then there's 6 pi over 3, which is 2 pi. And you can see that I've divided the circle into 6 pieces because my top pi is divided into 3, and my bottom pi is divided into 3. Because all the way around this circle is 2 pi, so half of it is just pi. Where then is negative 4 pi over 3? Well, remember, positive angles go that way, negative angles go that way. So I think I'm just going to count off 4 pi over 3's. So here's 1 pi over 3 going negative, here's 2 pi over 3's going negative, here's 3 pi over 3's going negative, and here's 4 pi over 3's going negative. So my negative 4 pi over 3 angle is this angle right here. And you can see that it is coterminal with a 2 pi over 3 angle. So what is the sine of a 2 pi over 3 angle? Well, I can see from the y value that it's radical 3 over 2. Or I could have drawn my little triangle here and realized that this was 60 degrees and this is 30 degrees. So this is my reference angle. I'm looking out at the side opposite, which is the long side. So again, I get radical 3 over 2. So going over to here, cosecant negative 4 pi over 3 is equal to 2 over radical 3. 2 over radical 3, because sine of negative 4 pi over 3 is equal to radical 3 over 2. So here is the answer to my first piece right here. 2 over radical 3. Now let's take a look at the second piece, secant 11 pi over 6. Well, I can go right to my unit circle, and I can see that I have an 11 pi over 6 angle. So my cosine of 11 pi over 6 is radical 3 over 2. My sine of 11 pi over 6 is negative 1/2. I'm looking for secant 11 pi over 6. And going over to here in my 6-pack, I can see that secant is the reciprocal of the cosine. So I go back here, I see my cosine is radical 3 over 2. Well, then the reciprocal of that is, so secant 11 pi over 6, well, it also happens to be 2 over radical 3. So my question now becomes, adding together, let's get a different color, cosecant negative 4 pi over 3, so that is 2 over radical 3, plus secant 11 pi over 6, well, that's also 2 over radical 3. So if I'm adding those two together, I'm going to get 4 over radical 3. And that's my answer. Now just remember again, with just a little bit of old arithmetic issues, if I have a common denominator, all I'm doing is I'm adding the numerator. It's the same thing as if I took 1/5 plus 2/5, that's going to be 3/5. Well, I don't have fifths, I have radical 3's, but the common denominator stays the same, so that's why that's the same, and I just add across and I get 4. So that is the answer to this problem.